Welcome back. Let's do 1.5 and 3.5, the limits at infinity and infinite limits, day 2 video. Let me slip ahead. In class, we had not finished, I need to go back, all the problems from this section of the notes. And mainly what we need to do is let's look at what's happening when we go to negative infinity. So if I wanted to evaluate this function at negative infinity, well, I know one of the things I can kind of sneak a look at is look at the highest degree on top, highest degree on bottom. This tells me my limit probably is moving, or my limit is moving to 2, which indicates I have a horizontal asymptote at 2, which indeed we can see on the picture to the right. But if I wanted to prove algebraically that I have an asymptote at 2, I would take that approach of dividing every term, we'll leave some space, by the highest degree in the denominator. And my highest degree in the denominator is at x squared. So every term will get divided by x squared. So I got them all divided by x squared. Now let's analyze what's happening on each of those. This one is headed to 2. This 7x divided by x squared will be headed to 0. 6 divided by something large will be 0. If I take a negative infinity and square it, which is what I'm really thinking in my head, this will be a positive infinity, and this is same over same, so this is headed to 1. Bottom heavy, this is going to go to 0, and this is going to go to 0. So I get 2 over 1, and there's that horizontal asymptote at 2. So x, not an x equal, a y equal, because we had a horizontal line, y equals 2. Looking at the next one, what are you going to divide by? If I want to evaluate this limit as x travels to negative infinity, I look at the denominator, I find the highest degree in the denominator. That forces my eye to x. So go ahead and do your work showing the division by x. Once I have that done, let's analyze the limit. And here I've got x squared divided by x. Well, that's going to behave, isn't it? It's going to behave like an x if I simplify. And if I put in negative infinity into this, that's going to take this limit to negative infinity. 3x divided by x, well, that's going to be like a 3 there. And 2 divided by x, that's going to go to 0. On the bottom, I have x over x, which cancels or reduces to 1. 1 divided by a value that's large will take it to 0. So in my denominator, I'm going to have a 1 value. And up on top, I'm going to have negative infinity plus some real tiny stuff. It looks like I'm going to get negative infinity. The answer to this particular problem, as x heads to negative infinity of this function, which I'm just going to call f of x, rather than writing it all, heads to negative infinity. What does that mean to you? Well, to me, it means as I travel out the x-axis and I'm approaching negative infinity, I'm getting very, very far to the left, I expect the curve to be headed to negative infinity, and indeed we see that happening. There's also a horizontal or a slant asymptote on this one, and if you check out this function, it is the same function that we calculated up earlier on the page, only in that case we were taking x and moving it to positive infinity. And when we took it to positive infinity, so as I traveled out to the far right, we noticed that our function is headed to the to positive infinity. And then we showed how to do synthetic division on that and come up with the equation y equals x plus 4. So just really be careful about negative infinity. But if you do this work of dividing by the highest degree in the bottom, it should come out with either the positive or negative that is appropriate for the problem. Now, the last thing here, let's look here at just a little recap. Graphically, a limit at infinity can yield either a horizontal or a slant asymptote. Horizontal or slant asymptote. And I'm just going to abbreviate. In pre-calculus, we discovered through observation that such a graphical property existed by comparing the degree of the numerator to the degree of the denominator. So the degree of the denominator. From this point forward, when we're working in calculus, this was not a viable justification for the existence of a horizontal or slant asymptote. What will be accepted is looking at it from a limit perspective. So if we want to justify the existence of a horizontal asymptote, we're going to use limits. And y equals c is the equation that we're looking for. Y equals c is a horizontal asymptote of f of x if and only if the limit, let me put it in a different color on top of that gray background, the limit as x heads to infinity, so let's look at end behavior, of a function equals a value c, some constant c. Or if we look at the limit as we head to the left end behavior, as I head to negative infinity of f of x, it may equal some constant c. And it can be the case that that c value is the same as I head to infinity and negative infinity. It also could be that they are different values. For the function below, find the horizontal asymptote if it exists, and then justify your answer using this reasoning about the limit as we approach infinity or negative infinity. So what I want us to do is we're taking just a nice rational function here. If I ask you to prove that it has a horizontal asymptote, I know I want to look at end behavior. So kind of connect those two together. And I think it will help you remember. So I want to look at end behavior. It will help you remember, well, end behavior means I'm going far to the right, like infinity, or I'm going to head far to the left with negative infinity. So our function, I'm going to divide by the highest degree on the bottom. So I'm going to just hit pause here and get it written down. Why don't you do the same? Okay, I when showed my work, I'm going to divide every term by 3x squared. In analysis here, I'm going to say 5 divided by 3x squared. 5 divided by something large is going to go to 0. This will go to 0. It's bottom heavy. Here I get the cancellations. It appears to me that this function, be sure you catch this negative, is going to negative 2/3. Here this is going to cancel out and go to 1. Bottom heavy on this middle term, it'll head to 0. Bottom heavy going to 0. Add up your values across the top, and I have negative 2/3. On the bottom, I have a 1. Therefore, I have negative 2/3. Would it have made any difference? This would be, right end behavior, because I'm looking at positive infinity. Would it be different? Would I have a different horizontal asymptote if I went to negative infinity? If I did a quick analysis, let's just write this much down of negative infinity of our function h of x, it would essentially look the same as what we were working on up here. We would divide by the 3x squared. And nowhere do I see an x remaining. Here, this would still simplify to negative 2/3 because my x squareds are canceling. Down here, this is going to 1 no matter what. This is bottom heavy, bottom heavy. This will end up with the same exact answer. So left and right behavior is identical, or are identical. Left and right, this is left behavior, is the same. So clearly I have a horizontal asymptote. Horizontal asymptote exists, doesn't it? And my equation would be y equals negative 2/3 And I could say because the limit as x approaches positive and negative infinity of my function h of x equals negative 2/3. And that would be justification. Finally, we have this last graph, the algebraic analysis described above to evaluate limits at infinity can be used to find limits at infinity for any type of rational function, even those with radicals. And I have it graphed over to the right so you can see what the picture looks like. What is the one thing that you notice that's different about the graph of this rational function versus all those others kind of that we've investigated in the past? Well, one thing I noticed, and I'm going to highlight it here, is I have an asymptote up above and I have this asymptote down below. So it looks like we have two asymptotes here. There are two different horizontal asymptotes. I want to show you how to find your limits when dealing with a radical. It looks, a little bit different. What I need to do is, what is my highest degree in the bottom? I'm still asking myself that same question, and my eyes go right there. The highest degree in the bottom is the square root of x squared, the square root of x squared, which is much the same as an x, isn't it? These are equivalent. Keep that in mind. So I'm going to do the same thing that I did before. I'm going to analyze it by dividing everything by the square root of x squared. So if you want to hit pause and finish this off and then come back and check your work, that's fine. Okay, so I did the same thing that we've been doing all along. I'm taking and dividing by the square root of x. So I took the square root of x squared and divided it by the square root of x squared. And I just extended my radical so that it's going over both the numerator and denominator. Same thing to the 1, I divided it by x squared. Notice how it's still inside the radical. Up on top, on the numerator portion of our complex fraction here, I have 2x that I just divided by x. Well, down here, why did I divide by x squared? And here I'm choosing to divide by x. Well, down here, this is really like the square root of x, isn't it? It's got the radical over it. Up on top, remember, we had the square root of x squared being equivalent to just x. It simplifies to x. So I can simply divide by x up on top. Now, when I analyze the results here, I am going to say that 2x divided by x, that cancels. This thing's headed to 2. 2 divided by x, it's bottom heavy, that's headed to 0. This is headed to 1. This is headed to 0. This is a 1 inside a radical sign, which is equivalent to 1. So I get a 1 for the denominator. And up on top, I get 2. My horizontal asymptote is at 2. Horizontal asymptote at 2. So I have a y equals 2 equation to describe the horizontal line. And then we need to analyze the other one, and hopefully, I'm sorry you guys, I didn't pay attention that this was negative here, the negative sign. Would that impact us? And it ought to, because it needs to be going to -2. To explain why this is going to -2, I'm going to show you that sometimes once I get my answer, I really need to, because everything canceled here, right? These x's canceled. I'm not picking up that this should have been -2 off this. This is headed to 0, this is headed to 0, and this here is headed to 1. So how am I going to show that this has -2? Because I know by my picture, as I head to negative infinity, I have an asymptote here at y equals -2. Well, the way that you can do it is go back to your original function. So I'm going to check the sign by going back to my original function and plugging in positives or negatives. And I want to go to negative infinity, so I have 2 times a negative number, -2, divided by the square root of a negative value getting squared plus 1. On top, I will have a negative value. on bottom, I have the square root of a negative being squared, which will be positive. And here you can see why it comes out to be negative, and this answer will then be -2. I would do the same exact analysis on the right-hand side here to look at right behavior at infinity. And then I could come back down and do the original function. This would be a positive amount. This would be a positive, and positive divided by positive is going to yield us a +2, so that we have horizontal asymptotes at 2. We'll get some more practice on this in homework. So you're ready for Monday. We did this page already for notes in class. So hang on to Monday. See you then.